This is John Black, Super Chemist. We're on part 10, Polarizers Fundamentals, and the 3 Polarizer Paradox. If you watched the last 2 videos, there's going to be a lot of repeat stuff in this video. Maybe skip on to the next video where we get into the quantum entanglement. We're going to look at Minute Physics video, and he's going to ask all these stupid things and say stupid things, and we'll answer all his questions. Which, if you watched all my videos previously to this in this series, you should be able to answer along with me. You should know. But then at the end of this video, he will mention quantum entanglement, and then we'll get into the last thing we were going to talk about with polarizers, which was quantum entanglement, which is a joke. See, here's the filter. It's vertical. That means the wires inside are horizontal. When the red guy comes in, a photon, right, he's at the bottom here, he's oscillating horizontal. That means he can induce all that power into this horizontal wire here. So you induce a horizontal current, and that induces a vertical magnetic, the B field gets oscillated, right? And the photon gets absorbed by the filter. But you have to, this induced current, think about it, you have to jump from here to here to here. These are atoms in the metal or iodine, and you know, if you're using polyvinyl polymer, the electron has to jump all the way, you know, has to leave its orbit and come all the way over here. The only way you can do this is if you are 100% 90 degrees. If you're at 89.999, you don't have enough energy to do this horizontal inducement of current. Okay, so you know, if you're at 89.999, where does all that energy go? You don't have enough to jump this electron off into the next atom or iodine atom, right? But I want you to look, the fields that they produce, they all line up, they're the same, you know what I mean? So there's zero torque, right? Now, like, if the guy comes in and the photon in the E field is vertical, none of that power can translate to the horizontal because he is 90 degrees off. That means zero energy, zero force, zero whatever translates over. Okay, but he can induce a vertical. But look, this is horizontal is going from atom to atom, going through the whole wire. Vertical, you would think, would be up and down like this, you know what I mean? Inside, this is the diameter of this wire. No, it is not. Okay, it's not jiggling the whole diameter of this wire. It's just the solar system part. You know what I mean? It jiggles inside within the solar system of the atom on here. Since you can't induce a whole current, you know what I mean? Your induced E field, right, is small. You can't induce into the horizontal, so none of your power goes that way. Because it's 90 degrees, but you can't do the vertical, but you can only jiggle it vertical up and down, right? It's going to jiggle, the most you can jiggle it up and down, because you're just talking about a solar system. You're not even talking about the diameter of the wire, okay? But out of jiggles, this is the biggest jiggle you can get, right? But you can see the red going up and down the B field. They're not as big as over here, right? This one is smaller, but it's the biggest jiggle you can get. Then when let's say you go 1 degree off. Let's say you go 1 degree off here, and here you're 89 degrees off, okay? Here, you almost, you know, you can't have as big a jiggle as this, but you get a jiggle almost as big as that, okay? And that, in turn, makes a B field in the polarizer, right? But it's tiny, it's slightly tinier, okay? Then you go down to all the way down to 89 degrees difference in the polarizer. You barely make any, because you can't translate any of the horizontal because you don't have enough to get it jumping from atom to atom, man, or iodine to iodine atom. So you can only translate it into jiggles in the vertical. And you can see you barely get any E jiggle. So if you get barely any E jiggle, you get barely any B jiggle, right? And then you can see it just gets smaller and smaller. Everyone in between would just be smaller and smaller and smaller. So what does this mean? That means you get smaller and smaller torque. So the E field in the photon dictates how big the E field is induced in the filter. Okay, unless you're at 90 degrees, you're going to induce vertically, because it's either you got enough energy to jump to the next atom or you don't. And the only energy that goes into this vertical thing is the vertical energy. Here it has 100% vertical energy, so it jiggles just as much, as it can. But here it's got a little bit less, so the part of this vector that goes in the horizontal cannot be translated over to this E field in the polarizer, right? So it's a little bit smaller. This one, he has even more into the horizontal, so he barely has any inducement in the E field. Okay, and the E field in the polarizer dictates the size of the B field, and the B field, right, dictates the torque, right, and the torque is dictated by this oscillating B field on the photon. If keep in mind, the line is not the B field, okay? The oscillating B field is just like this, like my red dot there. It goes back and forth, back and forth, back and forth. When it's over here in its oscillation, it is furthest away from this little tiny thing that the magnet thingy induced, right? So he ain't going to make it through. Here, he's really close. He's actually going to make it through. That's why at 89 degrees, you still have a probability of getting through. Here, he made a big E field, so a big B field. So pretty much, no matter where your B field is oscillating, you're getting through. But here, it's the furthest away from this B field. So that's why even if you're at 0.00001% off, from the transmission axis, you still have a little bit not going to get through, even though this is very close to. And the reason why is because this one point right here, with the energy in the B field, that oscillates back and forth. When it's right here, it's furthest away, and that is rolling the dice, because this is the only point when you're only one degree off from the analyzer, right? This is the only place where you don't get enough torque to get you lined up to get through to the analyzer. All these other positions, so you still have a tiny bit of chance of not getting in. Just like over here, you have a tiny chance of getting in because your B field can be the closest, like over here instead of right here. It could be right here, even though none of these other spots are good. This one right here, and that's why your probabilities oscillate, because this oscillates. And the probabilities are oscillating, right, because your B field is oscillating, because your B field up here is oscillating, because your E field is oscillating up here, and this because your E field is oscillating here. It's like it's a chain reaction. Okay, see that? See how that? This has less torque, right? But it still has some torque. That's why even at 89 degrees, you still get a probability of getting through the filter. And what is your probability based on? It's based on this. It's based on how I go over this in my last two videos. So go watch them if you don't get this whole thing. Oh, this is minute physics, and 3 blue, 1 brown. They're collaborating. Let's see how long it takes them before they say the word quantum or just bring up magic.
If you have polarized sunglasses, you have a quantum measurement device.
What did that take? 3 seconds? Oh my God, 3 seconds. Oh, you have a quantum. These people think that they can just attach quantum to something and it makes it all sci-fi. Like oh, my car's sci-fi. I got a quantum spark plug. So I got a quantum gas tank. Oh yeah. I got the quantum spark plugs are right next to the Canooter valve, right underneath the flux capacitor. Yeah.
Each of these pieces of glass is what's called a polarizing filter, which means when a photon of light reaches the glass, it either passes through or it doesn't. And whether or not it passes through is effectively a measurement of whether or not that photon is polarized in a given direction.
For old photographic filters, look through one set of sunglasses at some light source, like a lamp, then hold a second polarizing filter between you and the light. As you rotate that second filter, the lamp will look lighter and darker. It should look darkest when the second filter is oriented 90 degrees off from the first. What you're observing is that the photons with polarization that allows them to pass through a filter along one axis have a much lower probability of passing through a second filter along a perpendicular axis. In principle, 0 probability.
But here's where things get quantumly bizarre.
It's not just bizarre, it's quantumly bizarre. It's like These people are freaks.
All these filters do is remove light. All these filters do is remove light. And then
There's the first lie.
all these filters do is remove light.
Okay? No, it doesn't just filter light. Okay? The light it lets through, it reorients them into all having the same plane of oscillation with their E field. Okay? He knows it. He knows when it comes out of this, it's this, has this, and if it comes out of here, it has that. You know, the oscillation is that plane and this plane. If it comes out of it, he knows this. So he knows that they rotate the photons. Why is he a big lie? Is he really this stupid?
Remove light. They filter it out. But if you take a third filter and orient it 45 degrees off from that first one, and then you put it in between the two, the lamp actually looks brighter.
Yeah, because before you were putting it vertically through a horizontal. That's 90 degrees difference. Now you put it through this one that rotated it to 45. Now when it goes through the 90-degree polarizer, the light has been rotated to be 45 degrees difference instead of 90-degree difference. He knows this, but he acts like it's all quantum. It's quantum. Everything is quantum, you moron. This thing that everything is quantum, okay? And I understand that quantum has two things. One is going down to the smallest part. You can't take the parts any more parts apart. That's it. You got that part, and there's no. You can't make smaller parts out of that. But it doesn't make it magic. That's what's funny. What did you expect would happen when you went down to the smallest thing? You just keep going, and there'd be more smaller parts and more smaller parts, and it would just go on forever. Like they act like having quantum parts is like magic. No, it's just common sense, you moron.
This is not the middle filter generating more light. Somehow, introducing another filter actually lets more light through.
Yeah, because you rotated it. The two first filters are 45 degrees off, so half the light went through, but you rotated that 50%. So now that it can go through this one, you moron.
With perfect filters, if you keep adding more and more in between at in-between angles, this trend actually continues.
Yeah, because you rotate it more and more and more and more and more. And each time, the difference between the one filter and the next filter is very little. Very little. So you filter very little. Okay? Over here, you're filtering a lot because there's a big difference in between your arrows. Look at this. These are close. These arrows are far apart.
This feels super weird, but it's not just weird that more light...
Why is it super weird? And what's funny is, we all know, if you watch my previous videos, a polarizer is literally, I'm not saying it's like, or it's an analogy, or it's similar. No, it is an antenna, okay? Literally, okay? It's just an antenna for visible light instead of radio waves that are not visible light. That's the only difference. And the thing that it rotates the light. Other than that, it's a specialized antenna that rotates stuff. Radio waves are invisible light. Okay, here's a visible. See there, and here's a radio wave. They're the same exact thing. It's just the radio wave has a longer wavelength, and because of that, it's invisible to us. It's still a photon. Antennas for radios are about photons.
Comes through. When you dig in quantitatively to exactly how much more light comes through, the numbers don't just seem too high, they seem impossibly high. And when we tug at this thread, it leads to an experiment a little more sophisticated than this sunglasses demo that forces us to question some very basic assumptions we have about the way the universe works.
The entanglement is a joke, okay? It's a joke.
Like that the results of experiments describe properties of the thing you're experimenting on, and that cause and effect don't travel faster than the speed of light. These will come into question.
Physics will just break down. Oh my God, these people are morons.
Where we're headed is Bell's theorem, one of the most thought-provoking discoveries in modern physics. And to appreciate it, I really do think it's worth understanding a little of the math that we use to represent quantum states, like the polarization of a photon. And
see, that's the problem. They worship at the altar of the math god, okay? And whatever the math god says, even if it's the math god says leprechauns came out and did it, hey, then leprechauns came out and did it, okay? If they would just use common sense in any way, shape, or form, this is not be happening. This is ridiculous. Of course, it's leprechauns.